before we do the new lecture, let's review identities again here. We know in this unit circle, t is the angle. So sine t is actually y. In this special case is 1/2 when t is pi/6. Cosine t is actually x. Okay, because this is a unit circle, means the radius is 1. So then we have a y is special value 1/2, and x is another special value, radical 3/2. And we know in this right triangle, y squared plus x squared is 1 squared. And we know y is sine and x is cosine. So sine t squared plus cosine t squared is 1. Or you may say y squared plus x squared is 1. Okay. From here, we can do two things. Let me move this up a little bit. One thing is that if you use x squared to divide both sides, and x is actually cosine, okay, and the y is actually sine. X squared divided by x squared is 1. Sine over cosine is tangent, and 1 over cosine is secant. Okay, then you get the identity is that 1 plus tangent t squared is secant t squared. You may think here 1 divided by cosine x squared, how can you get a square? 1 without square. But 1 is actually 1 squared. Okay? So there is no problem about that. So we will use this identity in our following lecture, in this lecture. Yeah. And here also, if both sides down here divided by y squared instead of x squared, then you get another identity. It's because down here y is sine and x is cosine, so y divided by y, then squared is 1, plus x over y. X is cosine and y is sine, so cosine divided by sine is cotangent, and then squared. Okay, again here 1 is 1 squared, so then you have a 1 over sine is cosecant x, then you square it. Okay, so these two identities is actually from the same one. So this one is actually the basic one. From here you can find out another two. Okay, so I suggest just to remember this one. You may not remember those two, but you can derive it yourself. Okay, that's the way I study. Okay, I don't try to remember these two. If you get this one, you'll find out this two. Okay, once you need it, you always start from here, and then you can be sure those two will be correct. Now, let's look at the example. Since we'll use this two, I will leave it down here. Okay. Now let's look at the example right here. This example says that make the trigonometric substitution x equals a times sine theta for theta in between those two values and a greater than 0. Use identities to simplify the resulting expression. Simplify this one by substitution. Replace x with a sine theta. Let's see how it goes. Okay, so you may do like this. Always copy it. And then square downstairs. And then do the substitution. A squared, you leave it. X, you're going to replace with a sine theta. Okay, so minus a sine theta, and then squared. Okay, and then divided by x. And you have a sine theta, then squared. Okay. Yeah, keep going. Upstairs is a squared minus a squared sine theta squared over a squared sine theta and then squared. Remember, there is a 1 in front of it. So if you pull a out, a square out, you have 1 minus sine theta and then squared. Now divided by a squared sine theta and then squared. Okay? Now keep going. Equals squared, you have a radical sign, get a out. Okay, and then inside you may put radical. A is out here. 1 minus sine theta. Up to now, probably you remember that's cosine what? Theta squared. Okay, and then over a squared sine theta squared. Keep going. You have a is actually a to the first, and you have a downstairs. So there is a 1 over a in front of it. Yeah, I need to move up a little bit. Also this one. Yeah. Okay. Great. Now cosine theta squared, choose radical. You have a cosine theta. Okay. And then you have a sine theta squared downstairs. You may write like this. Sine theta sine theta. Okay. Why do we need to do that? Because you can do is 1 over a cosine, sine as cotangent. So you don't have a denominator as the purpose. And then for 1 over sine as cosecant theta. Okay, in this way you simplified. Oh, I really didn't use this identity here in this example. But I hope you may probably use it in different place, and this might be helpful for you to remember how did I get these two identities. Okay. Okay. One more example. I'll take this one away. Another example is this one.